በመቀጠል የምናየው extreme values for functions of several variables. As we know, extreme value ለመፈለግ critical point ያስፈልገናል. Previously discussed እንዳደረግነው critical points for a single variable function, it's the point at which the derivative either becomes zero or undefined. It's the same in the case of functions with several variables. Let's take functions of two variables. We have a point AB in the domain. Then this point is said to be the critical point if at least one of the following conditions is satisfied. The partial derivative, both partial derivatives must be zero at the same time. When ደግሞ the partial derivatives, one of the partial derivatives must be undefined. One of the partial derivatives አንዱ ሊሆን ይችላል. The relative extreme values, if any occur, are at the critical point. እንደምናውቀው critical point for a single variable ሁሌ relative extreme value ነው የሚሰጠን። ነገር ግን for functions of two variables ሁሌ extreme value ሊያሰጠን ይችላል, which means there are critical points which do not give relative extremes and they are called saddle points. So as an example ይሄኛውን function እንይ። መጀመሪያ the partial derivative with respect to x and y ማግኘት አለብን። ስለዚህ fx the partial derivatives ይሄንን ይመስላሉ። ስለዚህ የመጀመሪያውን ኮንዲሽን እና የሁለተኛውን ኮንዲሽን አፕላይ እናደርጋለን። fx is equal to 0, which implies that 3x squared minus 12 is equal to 0. In this case x squared 4 ይሆናል። x is equal to minus 2 and 2 አለን ማለት ነው። fy again is equal to 0. still የመጀመሪያው ኬዝ ላይ ነን። this implies that 2y minus 6 divided by the square root of 2 times is equal to 0. ስለዚህ እዚህ ጋር 2y minus 6 is equal to 0, y is equal to 3. አሁን እዚህ ጋር የመጀመሪያ ሴት ኦፍ ክሪቲካል ፖይንትስ ማግኘት እንችላለን, which is minus 2 3 እና 2 3. ነገር ግን እነዚህ ፖይንቶች they are not part of the domain of the function. ማለትም እነዚህን ፖይንቶች ፋንክሽናችን ላይ ሰብስቲቲዩት ብናደርገው undefined የሆነ ቫልዩ ነው የሚመጣው። ስለዚህ ክሪቲካል ፖይንት ሊሆኑ አይችሉም። ክሪቲካል ፖይንት ባይ ዴፊኒሽን ምንድነው ያልነው ቅድም? it has to be part of the domain of the given function. ስለዚህ እነዚህ ሁለቱ ሊሆኑ አይችሉም ማለት ነው። ከዛ ሁለተኛው ኬስ አፕላይ እናደርጋለን። ሁለተኛው ኬስ it's fy is non-existent. ስለዚህ ይሄኛው undefined የሚሆነው if this becomes 0 or less than 0. ስለዚህ which means this implies that 2 times the square root of y square minus 6y 0 የሚሆንበት ኬስ እናያለን። y into y minus 6 is equal to 0. ስለዚህ y is equal to 0 ወይም 6. ስለዚህ ክሪቲካል ፖይንታችን የነዚህና የነዚህ ኮምቢኔሽን ነው የሚሆነው ማለት ነው። ማለትም minus 2 0 minus 2 6 2 0 እና 2 6 ይሆናል ማለት ነው። ቀጣይ የምናየው it's how to determine the relative extreme values and second derivative tests. Relative extreme values እንደምናውቀው are values which are found at the critical points of a given function. The second derivative test is a test used to determine the existence of a relative extreme, not the actual relative extreme value but the existence of it. ወይም ደግሞ it's again used to determine the saddle point. So let's say we have a function that has continuous second partial derivatives. Then let D be the matrix form of the partial derivatives. We have 4 partial derivatives for a function with 2 variables. ስለዚህ በሜትሪክስ ፎርም አስቀምጠን ዲተርሚናንቱን ብናገኝ በዛ ዲተርሚናንት መሰረት አራት የተለያየ ኬዝ ይኖራል። እንደምናየው እዚህ ጋር if D is greater than 0 and if the second partial derivative with respect to x is less than 0, relative maximum value ይኖረናል። በዛ D greater than 0 ሆኖ the second partial derivative with respect to x ደግሞ greater than 0 ከሆነ f relative minimum value ይኖራል እና የመሳሰሉት። ስለዚህ በዚህ መሰረት አንድ ሲምፕል የሆነ ኤግዛምፕል እናያለን። የመጀመሪያ ስቴፓችን የሚሆነው ኢትስ ፋይንዲንግ ዲ ክሪቲካል ፖይንትስ። ቱ ፋይንድ ዲ ክሪቲካል ፖይንትስ የመጀመሪያው ኬዛችን ምንድን ነው? ኤፍ ኤክስ ኢዝ ኢኳል ቱ 0 ነው። ስለዚህ ዲስ ኢምፕላይስ ዳት ኤፍ ኤክስ ይሄ ይመጣል። ስለዚህ ኤፍ ኤክስ ኢዝ ኢኳል ቱ 0 ኢምፕላይስ ዳት 12 to x square minus 1 is equal to 0, which is also the same as 12 into x minus 1 times x plus 1. ስለዚህ critical points in x 1 እና minus 1 ናቸው። ከዛ ደግሞ fy is equal to 0 የሚለውን እንጠቀማለን, which implies that the partial derivative of f with respect to y ይሄ ይመጣል ማለት ነው። ስለዚህ fy is equal to 0 ማለት this implies that 3y square minus 3 is equal to 0. 3 into y minus 1 times y plus 1 is equal to 0, which implies that y is equal to 1 and minus 1. ስለዚህ critical poinታችን is the combination of the following two. ስለዚህ our critical points one minus 1 minus 1 እና minus 1. ስለዚህ at these specific critical points relative maximum ካልኩሌት እያደረግን ኦብዘርቭ እናደርጋለን ማለት ነው። ይህን የምናደርገው it's by using the second derivative test. ስለዚህ second derivative test ለመጠቀም the second partial derivative ያስፈልገናል። ስለዚህ the second partial derivative of x with respect to x ምን ይሆናል ማለት ነው? it's the derivative of 12x square minus 12 which is equal to 24x. fx ደግሞ with respect to y is equal to 0. fxy እና fyx are equal for a continuous function ተባብለናል። ስለዚህ fyxም 0 ነው። fy with respect to y ደግሞ is equal to 6y ማለት ነው። ስለዚህ at each point evaluate እናደርጋቸዋለን። ስለዚህ let's take out the point at the first critical point. Let's take this one. ስለዚህ our determinant of the matrix, the second partial derivative is 24 times 1, which is 24. This is 0, 0, and fyy is 6y, which is still 6. This determinant becomes 24 times 6 minus 0 times 0, which is 144, which is greater than 0. We know that fxx, which is at the point 1, 1, which is 24, is also greater than 0, which implies that there's a relative minimum point at 1, 1. በቀጣይ ደግሞ at 1 minus 1 እናያለን። at 1 minus 1 24x is 24, ሁለቱ 0 ናቸው። this is minus 6, which is equal to minus 144, which is less than 0. fxx እዚህ ጋር the second partial derivative at 1, 1 is still greater than 0, which implies that there is a relative there's a saddle point at the point 1 minus 1. ሶስተኛው ፖይንት ላይ ደግሞ at minus 1, 1 second derivative test በመጠቀም 24x at minus 1 is minus 24, 0, 0, and this is 6. Which is minus 144, which is still less than 0, which implies that there is a saddle point at minus 1, 1, and the final point, which is at minus 1, minus 1, our determinant will be equal to minus 24, 0, 0, and minus 6, which is positive 144, which is greater than 0. And the second partial derivative with respect to x is less than 0, which implies that there is a relative maximum at the point minus 1, minus 1. ስለዚህ as a note እነዚህን ሬሌቲቭ ማክሲመም ሳይድል ፖይንቶቹን ማግኘት እንችላለን። we just like critical ፖይንቱን at the function insert በማድረግ functional ቫልዩን ኢቫሉዌት በማድረግ የምናገኘው ፖይንት will be the relative minimum value, the relative maximum value and the saddle point ማለት ነው።